Hi, welcome to this class on understanding using the basic E6B flight computer. This is, in my view, one of the simplest methods of doing things, and you don't really need a electronic calculator. This, along with the basic scientific calculator, is enough for all your exams. So, in this class, we are going to see how to use this computer, right? So, what we are going to see is we'll see the overview of the flight computer. We'll see how to get ISA conditions, calculating speeds, that is TAS from IES, RAS or CAS, how to calculate TAS, Mach number from Mach number to TAS, and then we'll see how to calculate altitude, that is density altitude, and true altitude when the pressure altitude is given. Okay. Now, basically in this flight computer, there are two sides. One is this side. You have a rotating scale inside, and the outer side is a fixed one, right? And on the wind side, you have it goes up and down, and then you have a rotating dial inside. So in this class, this side, primarily the wind side, is used to solve the wind triangle problems, and we are not going to have a look at it at this stage, and sometime later in another class we'll have a look at that. In this class we are going to have a look how to use this slide, that is the slide rule side, right? So let's get started. Okay, now this side is a pretty simple one. On the outer side, you will find nomenclatures written, like imperial gallon is written here, kilometer is written here, and then you have kilometer written here again, US gallon. So these are on the inner side. This side is basically converting one quantity to another. This can be used for your unit conversions as well. So let's have a look, how do we just convert units on this side. This is pretty simple. You don't really have to do much hard work on this. And let's say I want to convert kilometers into nautical miles. So all I do is I see this kilometer written here, right? Okay, let's zoom in a little bit. Okay, so I see this kilometer written here, right? Here is the kilometer written. So if I want to convert nautical miles into kilometers, all I do is I rotate the inner scale and align this kilometer with the nautical mile. Okay, now you can see that the kilometer is aligned with the nautical mile, and now it is very easy for me to read. That means if I want to find out how many nautical miles is 20 kilometers equal to, so I just go here and read it out here. So 20 kilometers here, and how much do I read on the outer scale? I am reading against 20, you are reading 10, okay? And this is, every graduation is 1 nautical mile. So we see here 1, 2, 3, 4, 5, 6, 7, 8. It's about 10.8 nautical miles is equal to 20 kilometers. That's what my computer is telling me, and that's how you can use this outer scale. But we'll have a look at this once again, and you can play around with this. This is very simple to use as far as unit conversions go. For now, we'll get on to how to solve problems of navigation on this, right? So the first thing, how do we get ISA? That means if a question says that temperature at pressure altitude of flight level 200, let's say, is ISA minus 15. So now how do I know that what is the ISA temperature? Because once I know the ISA temperature, I can easily subtract 20 degrees from there and figure out the actual ambient temperature outside. So the simplest way to do it is, remember 10 on 10. You just align the 10 on the inner scale with the 10 on the outer scale. Align 10 on the inner scale with the 10 on the outer scale, and now we are ISA. That means that if I want to find out what is the temperature, ISA temperature at pressure altitude of 20,000 feet, or if I'm saying pressure altitude, it means that it is a flight level. So flight level 200 means 20,000 or 20,000 feet of pressure altitude. So all I need to do is look here, against 20 here, what is the temperature reading? It is reading minus 25. So under ISA conditions, the temperature at 20,000 feet of flight level 200 is minus 25. Okay, all right, so that's how you find the temperature at a given pressure altitude under ISA conditions. And then if you have been given ISA plus or minus, you can apply that plus or minus to find out the actual temperature at that pressure altitude at that state. Okay, now the next question is, how do we calculate speeds? To calculate speeds, you find here three windows, in fact, right? One on the left, one on the right, and one on top here, right? So for speed corrections, you see it is written here, airspeed corrections are carried out on this window, whereas the altitude corrections are carried out on this window. Altitude corrections here mean finding out the true altitude from the pressure altitude. But if we see the density altitude is read in this window marked as density altitude. That means this window has to be set to read the density altitude. And if you read here carefully, the instructions are also written. That is, for airspeed corrections, okay, set pressure altitude opposite degrees Celsius in the window. Opposite CAS on inner scale, read TAS on the outer scale, read density altitude at the center. So let's try to find out TAS from IES with the given set of conditions. That means, let's say the question is find TAS at let's say flight level 100, given temperature equal to minus 20 degrees Celsius, and RAS is let's say 200 knots. Okay, so how do we go about doing this? So we have to find out the TAS at flight level 100 given the temperature is minus 20 degrees Celsius and RAS is 200 knots. Okay, so what do we do? Flight level 100 means pressure altitude of 10,000 feet. So I'll rotate this window to put minus 20 degrees on this scale against pressure altitude of 10,000 feet on the inner scale. All right, so I have set my the inner scale now, and now I'm ready to read. So what do I do now? I go to CAS on the inner side. CAS on the inner side is 200, is here, 200 is here, and I read this is 222, 1 2 3 4 5. That means each window is of 2 knots. So against 200 I am reading this is about 225, 226 knots. So the answer is I get from here is 226 knots. Okay, so roughly if at flight level 100, if you're at minus 20 degrees Celsius and your IAS or rectified airspeed or CAS is given as 200 knots, your TAS is 226 knots. This is how to find out TAS when IAS, RAS or CAS is given and the temperature at that given altitude is known. Now let's say I didn't have this, and instead of this I had something like temperature was given as ISA plus 10. Okay, so what do we do? First what we will do is we'll find out what is the exact temperature, so for which I will get 10 on 10. Okay, and I'll see at flight level 100 the temperature should be minus 5. Okay, the temperature should be minus 5. Okay, so the temperature should be minus 5, and so temperature is minus 5 and it is given is plus 10. Plus 10 is given here, that means ISA plus 10, ISA plus 10. So ISA plus 10 is given here, so I say minus 5 plus 10, so my actual temperature here would be plus 5. Yeah, so my actual temperature is pardon me for this is not the best platform for that, but I'm just making to go through here. So it's I found out that flight level 100 temperature is plus 5. So now what do I do? At 100 I will set the temperature at plus 5 here. Okay, and now I read same 200 knots. 200 knots is here, and now this is reading 232 knots. 232 knots is the TAS. So that's how you can find out TAS when IAS, RAS, CAS is given, or exact temperature is given, or temperature is given in ISA plus or ISA minus. Okay, so this is how we can find out the TAS when the IAS, RAS, CAS is given and temperature either in terms of ISA plus minus or the exact temperature is given. Fine. Okay, sir. So now we see we'll see how to convert Mach number to TAS. Okay, so for which I will rotate this window till I get Mach number index on this window. Okay, let's say the question is OAT is equal to minus 30 degrees Celsius. Okay, calculate TAS if Mach number is 0.5. Okay, 0.5. Okay, 0.5 is pretty high, so let's put it as minus 0.4. Mach number is 0.4, OAT is minus 30 degrees Celsius. Calculate the TAS. So first I'll set up my window. That means I will put this to Mach number index, this little arrow here. I will put this little arrow against minus 30. Okay, ambient temperature is given minus 30. So I set it here. Okay, this is almost okay, minus 30. And now I read against Mach number on this line. When I say 0.4, that means I look here. 40 means 0.4 in terms of Mach number. So I look against 40. And against 40, I see the TAS as 244 knots. So answer is TAS is equal to 244 knots. Okay, and I got 244 from here, 244 or 245. Usually in the exams you will not get a difference of 1 knot, 2 knot. That could be because of errors. Okay, or if my TAS is given, okay, if my TAS is given, I can find out opposite. Like for this example, if I was given calculate Mach number, okay, calculate Mach number if TAS is equal to 260 knots. Okay, so everything remains same. I go to 260, I find 250, 60, 70, 80, 90, 300. So this is 60, right? 60 is here. So Mach number is 0.4 and this point, so this is 41, 42, 43, 44, 45, 41, 42. So Mach number is Mach number is 0.425. That is pretty simple, as simple as that. Okay, so this is pretty simple to use this tool. Okay, now the next is how do we calculate density altitude and true altitude. As I said, that for calculation of true altitude, the window that needs to be used is this one, and for calculation of density altitude you have to use this one. Okay, so density altitude can be calculated in two methods. You can use the formula, or probably you can use this window directly. Although if you use the formula, the results will be a little more accurate in terms of density altitude, since it's a little more critical parameter. Okay, so let's try to solve a problem. Okay, let's say the problem is given pressure altitude of 29,000 feet, OAT minus 55. Okay, 29055. Okay, so let's try and do this with the help of the calculator. Okay, so we get flight level 290 or pressure altitude is equal to 29,000 feet. Both are the same thing. Both are the same thing. You need to know the pressure altitude correctly for this. Right, pressure altitude and temperature is equal to minus 55 degrees Celsius. Okay. Yeah. So if I have to find out, okay, let's find density altitude and true altitude. Okay, let's first find out the density altitude using the computer straight. All right, so we are going to use this window, right? Temp OAT is minus 55, so I'll set 290 minus 55. So 290 will be 25, 26, 7, 8, 9. This is 290, right? Okay, this is 290, and I have set it to, this is 1, 10, 20, 30, 40, 50. This is minus 55. So I set So I set 290 against minus 55 here. Okay, now let's see what is the density altitude. You can read the density altitude here. Your density altitude is 25,000, 26, 27, 27,500. Okay, so okay, you read here, this is sorry, let's try to draw a straight line. Okay, density altitude is here. You read here against this, and this is 27,500 feet is your density altitude. Okay, so your density altitude is lower. That means you're lower than ISA, right? You're lower than ISA. So if OAT is minus 55, let's check out what should be the OAT at under ISA. So I expect the OAT under ISA to be a little higher than minus 55. It should be close to minus 45 or something like that. Let's try out. So to find out ISA, we put just 10 on 10. 10 on 10. Okay, let's see what is the 290. 290 is here. Okay, so you see here ISA altitude, ISA temperature 290 should have been minus 44 or minus 43, something like that, but you got it at minus 55. So your ambient conditions are colder than what they should be in ISA, and that is why your density altitude is lower than your pressure altitude. Okay, now let's see how to find out the true altitude. For true altitude, we are going to use this window. Okay, we are going to use this window. That means that I'm going to set 290 against minus 55, which should be somewhere here. Okay, okay, so I have set 290, which is here, against minus 55, which is here. Okay, and now I am going to read my true altitude. Okay, let us see what is our true altitude. So for true altitude, I'm going to use the inner and I'm going to read on the outer. Okay, this is what I'm going to do. So let's see, where is 290 on this? So this is 25, 26, 27, 28, 29. 29 is here. Okay, and what is it? 25, 26, 27, 27, 400, right? So this is 25, this is 26, this is 27, and 27, 200, 27, 400. So the true altitude okay, altitude is equal to 27,400 feet. That's pretty simple. And density altitude is equal to, we found out, 27,500 feet. Yeah, you could also find out the density altitude using the formula. That is the formula is okay, what is the formula? Let's see, the formula is 290 minus 120 into ISA deviation is the formula, right? So what we do for that is we find out what is the ISA. So we do 10 on 10 and we find 290 should be about minus 43. Yeah, so let's put it like this: ISA is equal to minus 43 actual is minus 55. So we are in ISA minus 12 conditions, right? We are in ISA minus 12 conditions. ISA minus 12 conditions is where we are. Okay, so it is simple now. If you're in ISA plus 12, then the density altitude is equal to 29,000 feet minus, okay, it should be plus 120 multiplied by minus 12. Okay, that will give us 29,000 minus 120 into 12. Let's see how much is it. Calculator. So calculator is 120 into 12, 1440 minus 1440, which is let's call the calculator again. 29,000 minus 1440 gives you 27560. 27560, or so see the difference we got from here. We got okay, we got 27,500 from the computer directly, and we got 27560 by using the calculation, which is not very different, right? It's nearly within 100 feet, so you can use either ones. But if you're finding that in the questions the options are very close to each other, it's always better to go with the formula rather than going with the results that you got out of the density altitude. Exactly. Okay, so this is how to use the flight computer for solving basic speed, TAS, Mach number, altitude, density altitude, and true altitude. Right. So thank you very much for understanding this. If you have any questions, you can mail me at abby@winglet.in. Thank you very much, and that's about it for now. Thank you.